Rumors of odd happenings on the moon have long been written off as conspiracies. About to be put up for auction are 3 missing NASA videotape recordings of the first moon landing. However, astronauts' leaked video is now transforming those murmurs into overwhelming inquiries. Were these images, these secrets, this part of the moon purposefully kept out of the public eye? What were the actual experiences of astronauts on the moon? And why did this knowledge take so long to come to light? The monoliths on Mars and Phobos. Numerous geological structures that have been sculpted by impacts, volcanic activity, and erosion can be seen on Mars' surface. An item commonly known as the Mars Monolith is one of the noteworthy curiosities that satellites have captured. This feature can be seen as a rectangular block that stands out sharply from the surrounding landscape in photos captured by the Mars Reconnaissance Orbiter, or MRO. Its ostensibly straight edges stand out more because it is situated in a region that is otherwise rough. Is that Mars moon? A monolith can be found there. This has a really interesting structure. According to official data, natural fracturing processes and sedimentary or basaltic rock, where vertical or horizontal forces produce reasonably clean cracks, may have created such a block. Debris surrounding the block may be removed over time by wind erosion. When observed from orbit, that can result in a freestanding shape that seems odd, particularly if the lighting happens to accentuate shadow lines. Another feature on Phobos, the small moon of Mars, has been dubbed Phobos Monolith. Photographs reveal an object on or close to the moon's surface that appears remarkably huge. It is sometimes said that the monolith on Phobos casts a large shadow, indicating a significant height in relation to the surroundings. The irregularly shaped moon, Phobos, is frequently struck by meteoroids, which can leave behind tall rock or debris formations. The asymmetrical gravity field of the moon also causes some surface materials to shift. Random blocks from impacts or tectonic-like fracturing are typically used to explain seemingly monolithic forms in the broader context of planetary geology. Despite the fact that Mars lacks Earth's current plate tectonics, ancient processes, volcanic intrusions, and the repeated impact can cause fissures that result in rectilinear slabs. The rock's composition, the angle of fractures, and the erosional forces operating on these monoliths can all affect how uniform or smooth they are. Color and brightness shifts in orbiter returned photographs further highlight edges that may not be as distinct when seen in different lighting conditions or at different times of day. The top of the Mars monolith appears to be quite flat in some photos, but the surrounding terrain appears more rocky or sloping, because it gives the impression that the monolith was placed purposefully. This effect attracts more attention. The Phobos monolith, which stands out against an uneven background, is comparable. Measurements of the shadows created by these monoliths are among the data obtained by orbiters. Researchers can determine the approximate height or vertical relief from these shadows. Estimates of height on Mars are influenced by the light angle and camera geometry. Although the moon's small size and erratic orbit make precise measurement on Phobos difficult, photos nevertheless clearly show a noticeable object. Because big blocks shed light on how materials decompose under stress, these shapes continue to be of geological importance. For hints on the magnitude of impacts or interior crustal fissures, scientists also examined their immediate environment, sightings of UFOs, and Santa Claus codes. Throughout the Apollo era, astronauts conducted a lot of observations while in space, and some of these observations garnered interest because they showed unknown objects near the spacecraft. In Apollo 11, there was a noteworthy incident where the crew mentioned something they were unable to instantly identify. In order to determine whether what they observed could be connected to their own hardware, the astronauts inquired about the whereabouts of expended rocket components and mission transcripts. According to official statistics, the SIVB, the third stage of the Saturn V, was located further away than the visually reported object. A term that has been employed in communications to characterize unknown things without frightening the public is referred to as Santa Claus in some discussions of this incident. Generally speaking, NASA has provided explanations that suggest that sunlight may be reflected by detached panels, ice particles, or other debris, particularly if the object is close by. A spacecraft's surroundings are made up of several pieces that can show up as bright spots moving strangely in relation to the windows of the crew cabin. Uncertain identifications on first sightings can occasionally result from light reflections, camera angles, and stark spatial casts where a small reflecting object can glow clearly against a dark background. There were other missions with complex sightings besides Apollo 11. Unexpected lights or objects that were monitored and frequently linked to known man-made detritus were mentioned by a number of Apollo crews. Small pieces of metal or insulation can stay close to a spacecraft in the vacuum of space for a while before vanishing or returning to the atmosphere if the spacecraft is in low Earth orbit. Although NASA has never officially classified the phrase Santa Claus as a code for unidentified flying objects, it is present in the public domain. Any mention of Santa Claus is often included in official mission logs as incidental or informal. Strict communication protocol was part of the Apollo program, according to extensive archive study. Therefore, if there were significant surprises that directly affected flight safety or mission goals, NASA would ask that they be communicated in confidence. Real-time flight controllers had to assess the distinction between normal debris sightings and possibly mission-critical anomalies. Although the precise identification was not yet known, the object that Apollo 11 saw was declared to be a piece of hardware that had previously been detached from the spacecraft. NASA openly acknowledges that debris behavior can be unpredictable since even little changes in orientation and velocity can cause an object to tumble or move in ways that the crew may not notice right away. The Moon Spire. In 1967, NASA's Lunar Orbiter program collected photos of the Moon in preparation for the future Apollo landing. One photograph in particular caught attention because it showed what seemed like a slender vertical building. This photograph, which suggests a vertical feature with a distinct shadow, has been referred to as proof of a moon spire. Like many other frames from that time period, the raw frame was scanned and processed in a way that may have introduced distortions or vertical lines, among other processing artifacts. Nevertheless, a closer look at the picture shows a feature that some people believe to be a real three-dimensional column sticking out of the moon. Photographic film was developed aboard the Lunar Orbiter spacecraft, scanned, and transmitted back to Earth by radio transmission. Linear streaks were occasionally the result of flaws in the film or the scanning apparatus. However, a typical imaging anomaly typically does not produce a distinct shadow that corresponds with an apparent item. This makes anything that looks like a tall spire remarkable. Unusual lighting angles may also draw attention to a protrusion on even ground or the rim of a tiny crater, giving the false impression of a slender pillar. Craters created by innumerable meteoroid and asteroid collisions over billions of years dominate lunar geology. Particularly in bigger craters, these impacts can produce intricate ridges, peaks, and core uplifts. Although large columns or spires are rarely observed, the Moon's ancient volcanic activity created the Maria basaltic plains. Images draw attention when they display features that don't look like the recognizable morphologies of craters. NASA's stated strategy for handling odd forms in older photos takes into account image resolution limitations, scanning flaws, and the ways that low sun angles can produce elongated shadows. Under severe lighting conditions, a small outcrop or ridge photographed may theoretically seem as a spire in a single shot. A granite formation that could withstand billions of years of meteor strikes without collapsing would be necessary for the existence of a separate vertical item. Large freestanding columns on the Moon are not specifically listed in any statistics. However, smaller lumps or rocks can still cast noticeable shadows. Although it can be challenging to replicate precise historical snapshot angles, high-resolution photographs of a large portion of the Moon's surface have been captured by modern lunar orbiters like the Lunar Reconnaissance Orbiter. There are no obvious tall towers or spires in other photos of the same general area. A big vertical structure is not confirmed by subsequent surveys, yet the earlier shot is nevertheless recognized for displaying an interesting shape. Official documents therefore describe it as a formed outcrop that seemed accentuated by illumination or as an unusual relic. The entire episode serves as a reminder of how unexpected alignments between lighting angles and film processes can lead to issues in single-frame photographs from past missions. The Mystery Hut of China. The Chang'e 4 projects U-22 rover, which is part of the Chang'e 4 mission and operates on the lunar far side, had an unusual sighting in December 2021, according to the China National Space Administration, CNSA. The rover's camera picked up a shape at a distance that became known as Mystery Hut. Blocky form that appeared to rise sharply above the horizon was visible in early photographs. Since the moon's far side is rarely visible from Earth, U-22 data offered new insights on the landscape and the objects that are dispersed throughout it. Because the lunar rover has limited power and mobility, the rover team planned a gradual approach to capture clearer photographs. New images taken over time showed that the object was actually a big, uneven boulder that was situated close to a crater. The illumination angle and limited resolution at the rover's highest camera zoom had contributed to the geometric appearance of the first, farther-off view. The actual features of the rock, which showed no symmetrical boundaries or artificial form, became increasingly apparent as U-22 got closer. Later, CNSA released close-up photos of a typical boulder. Being the first soft landing on the far side of the moon, China's Chang'e 4 mission holds historical significance. Signals from high latitudes or beyond the moon's barrier do not immediately connect to Earth, making communications in that region extremely difficult. A Quo relay satellite, which is positioned to enable data flow, is essential to the mission. The U-22 rover uses spectrometers, cameras, and ground-penetrating radar to examine the structure and makeup of the soil. Seeing seemingly odd items, such as the Mystery Hut, is a natural aspect of the exploration experience. In order to collect mineralogical information, find evidence of previous impacts, and document the layering of the regolith, distinct forms and boulders are inspected. Rocks ejected by meteor collisions are frequently found on the crater-riddled far side surface, and some of these rocks may settle in solitary locations. Photographers may exaggerate the appearance of some rocks because of the sharp shadows and great contrast created by harsh lighting and the moon's lack of air scattering. Low-resolution photos may appear to have more flawless edges at a distance. The illusions usually go away when the rover eventually conducts close-up investigations. With no known water or air to weather surfaces as on Earth, the Mystery Hut's final study verified a typical rock formation that may have broken off from a crater rim. Lunar boulders are capable of retaining odd silhouettes or sharp facets. Any visually striking formations increase public interest in robotic exploration of unexplored lunar land, while the rover's capacity to navigate and study these features provides important data on lunar geology. Transitory lunar phenomenon. Flashes or glows on the moon that come and go in brief bursts have been observed by observers for ages. The phrase transitory lunar phenomena, or TLP, is frequently used to describe these occurrences. As early as the 16th century, astronomers wrote down their observations of fleeting bright spots, color shifts, or mists. Even though observation has been improved by sophisticated telescope equipment, TLP is still recorded today. Lunar orbiters that detect brief increases in brightness have also documented certain events. Numerous theories have been put forth by researchers to explain TLP. One theory is that tiny meteoroids could regularly strike the Earth. Impacts can produce short, powerful flashes because the moon lacks an atmosphere to decelerate approaching debris. The idea that some regions of the lunar crust might retain volatile gases is the subject of another theory. If gas expands and interacts with solar radiation, little outgassing events may cause a localized glow or upset the regolith and reveal new material that reflects sunlight differently. A smaller category of research discusses the electrostatic charge of lunar dust, in which particular particles rise above the surface under specific circumstances and momentarily alter brightness by reflecting or scattering light. Astronomers, both professional and amateur, record the timings, locations, and intensities of TLP events. Historical documents have mentioned some places more frequently than others, such as the area around Aristarchus, the crater. Although connection was confounded by instrumentation, sensitivity, and coverage, the Apollo program, which installed seismometers on the surface, was unable to definitively link TLP episodes to direct seismic activity or major impacts. On the night side of the Moon, contemporary spacecraft sometimes detect brief variations in brightness that could be caused by meteor impacts. In order to distinguish between external collisions and any internal surface activity, instruments such as the European Space Agency Smart 1 have gathered data on specific TLP incidents. TLP is still an unanswered question despite centuries of reports. Some may be delusions brought on by the state of the eye. Others might result from actual locally occurring events that are still being investigated. TLP is typically approached by scientific investigations by comparing known phenomena, such as meteor showers or reported impacts, with recorded lights or glows. The ability of contemporary high-speed cameras and spectrometers to record transitory events in greater detail has improved the characterization of TLP. Testing for radon or other gas emissions and confirming the frequency of bright displays caused by tiny meteors are the main goals of ongoing observation projects. Despite not being formally categorized as unusual or unnatural processes, TLP's variety and unpredictability demonstrate the Moon's ongoing potential to experience sporadic and localized variability despite its lack of Earth's extensive tectonic or atmospheric dynamics. The Apollo 11 tapes are lost. One of humanity's most famous accomplishments came from the Apollo 11 mission in July 1969. Millions of people on Earth watched live as the first human footsteps were recorded on the Moon. The technical process required to transform the slow-scan television SSTV signal from the lunar module into a format appropriate for regular broadcast resulted in a lower resolution broadcast that viewers saw. Higher fidelity film, however, should have been retained by NASA's initial SSTV recordings. NASA conducted significant internal searches and public inquiries after announcing decades later that these original Apollo 11 tapes were not found in its archives. According to the official stance, NASA had storage issues in the late 1970s and early 1980s and either reused or deleted a large number of magnetic tapes. When the data were judged no longer vital, the CIA usually recorded over tapes, handling massive amounts of data from multiple missions and ground tests. The best explanation is that the SSTV tapes from Apollo 11 were a part of that standard process. Considering the historical significance of the Apollo 11 mission, this result was unexpected. However, NASA stated that no particular steps were taken at the time to separate and preserve the original slow-scan video. The missing reels were not found despite many inventory checks and searches of NASA's data centers. Subsequent investigations turned out copies or secondary recordings, some of which were of a greater caliber than the broadcasts from the archive network. These sources originated from staff members with direct downlink signal access or from storage at tracking stations. The renowned Apollo 11 movies have been improved as a result of NASA commissioning a restoration operation to scan and improve the finest copies available. Nevertheless, it fell short of the direct SSTV feed's theoretical clarity. According to engineering documentation, the SSTV transmission had fewer lines and was formatted at a rate of roughly 10 frames per second. As a result, the broadcast needed to use a method known as optical conversion, which involved actually pointing a TV camera at a dedicated monitor that showed the slow scan image. In that step, image detail was further diminished and generational loss was added. The potential erasure of the Apollo 11 tapes was an ugly but necessary aspect of data management at the time, as NASA's official literature emphasizes. Usually, the agency kept the experimental scientific data. A portion of the original Apollo 11 footage was recovered. However, several reels in NASA's vaults turned out to be mislabeled or damaged, even though significant volumes of video data occasionally got lower priority handling. The loss of the original tapes is nevertheless a lesson in archival management, even though they are no longer the main slow scan masters. It also shows that without rigorous cataloging and protection, even well-known content might be lost. Despite the loss of the original recording, the repaired material that is currently accessible is the best record of the momentous landing, guaranteeing that pictures of Apollo 11's lunar operations will continue to be widely shared. Moon water. When scientists discovered subtle indications of hydration in lunar soil samples, the long-held perception of the moon as a barren, waterless world started to change. When NASA's Lunar Crater Observation and Sensing Satellite mission purposefully struck a spent upper rocket stage into a permanently shadowed crater close to the moon's south pole in 2009, these early indications received a lot of support. Water ice was found in the following plume upon analysis, proving that cold traps in dark craters may sustain frozen volatiles for an extended period of time. NASA said in 2020 that it has used the Stratospheric Observatory for infrared astronomy to discover water molecules on illuminated areas of the lunar surface. Sophia, given that the moon's surface may get extremely hot, the existence of water in areas that receive sunlight was unexpected. If the water wasn't protected by shade, it was predicted to sublimate and spread quickly. Rather, evidence suggests that water might be present in trace amounts, perhaps in the form of glass-like beads created by micrometeor impacts or trapped in mineral grain flaws. These microenvironments could shield molecules from the high temperature fluctuations in vacuum. Higher amounts of ice are thought to be found in permanently shaded craters at the lunar poles because sunlight never reaches those regions, maintaining temperatures low enough to avoid sublimation. Radar observations and other remote sensing tools have often shown signals that have been interpreted as water ice formations. Research on the amount of ice and its burial depth is still ongoing. The goals of landers and rovers investigating the lunar poles are to determine its distribution, gauge its purity, and determine the most effective methods for removing ice for possible use. For space exploration, the moon's water content is practically significant. Water can be utilized directly for drinking and life support, or it can be divided into hydrogen and oxygen to make rocket propellant. The quantity and expense of supplies that must be launched from Earth could be decreased by locating readily accessible ice formations. By utilizing local water missions, space organizations can extend the duration or range of their missions and incorporate this discovery into their plans for sustainable outposts or long-term lunar bases. Other lunar constructions include the Shard. When examining Apollo photos, several seem to depict geological formations or buildings that deviate from the usual lunar landscape. The Shard, which may be seen in an image credited to the Apollo 10 mission, is one topic that is frequently brought up. A tall, narrow-looking formation with a sharp, irregular contour and a noticeable shadow can be seen in that picture. The Shard has no official NASA designation. However, the image has drawn notice since it appears to show a vertical feature rather than the typical lunar hills or craters. Tens of thousands of still photos were taken during the Apollo missions, many of which showed the extensively cratered Maria Highlands and transitional regions. Features with striking shadows can be emphasized by lighting angles close to the terminator, the moon's division between day and night. Small ridges, crater rims, or rocks may appear extended at low angles. Uncertain contrast added by film scanning can accentuate edges. One instance of a picture that appears to show a formation rising sharply above the surrounding landscape under specific circumstances is the Shard. The Apollo archives also contain allusions to bright or reflective domes and what is known as the castle, among other suspected lunar anomalies. These frequently show up in specific frames, where the camera angle or illumination creates the appearance of see-through forms or brilliant patches. Many of them are classified by NASA as either local geological lumps that took on a characteristic look under exceptional illumination, lens flares, or scanning artifacts. Particularly when an image is cropped or much enlarged, rocks with a slightly varied albedo can be easily identified. In particular, the shard appears in a black and white image that has not benefited from contemporary orbital imaging from the same perspective. Replicating the precise angle and lighting from 1969 or 1970 is extremely difficult, but modern lunar orbiters, like the Lunar Reconnaissance Orbiter, can discern objects down to a handful of meters in size. There are no notable towering freestanding towers in that area according to official references. The edges of crater walls, rieles, or tectonic-like fault scarps that do not resemble an isolated tower are usually the few known vertical landforms on the Moon. For mapping and documentation, Apollo cameras employed a variety of lens types, which could have distorted perspective in some frames. Furthermore, unusual effects can be created by the lunar environment's sharp shadows and stark contrast with direct sunshine. The shard's picture is captured as an intriguing but unconfirmed shape because it lacks sufficient background. According to mission data, cratering processes and volcanic flows provide a good explanation for the Moon's terrain. Large structures resembling spirals are not confirmed by official maps, even though pictures like the shard demonstrate how a single frame can start conversations about surprising formations. Repeated observations usually make it clear that only common geological forms exist. More recent high-resolution surveys do not reveal any towers in the area close to the shard photos, indicating that the dark night satellite may have appeared as a big, jagged outcrop due to the special lighting or scanning conditions of the older images. An photograph of a dark object floating against the background of space was taken during NASA's STS-88 space shuttle mission in 1998. During the mission, astronauts engaged in extravehicular activities, or EVVAs, to build components of the International Space Station. NASA determined that the object was a cover or thermal blanket that had come loose. During the EVA, images of the object taken at different times show its asymmetrical form. Such material can twist and take on shapes that are different from a flat sheet in microgravity. The astronauts were unable to recover the missing insulation or cover before it flew away, according to NASA's mission notes. Small objects, including his tools and protective covers, can sometimes detach from spacecraft, according to agency documentation. These objects are part of the orbital debris list. In other frames, the object shape appears more solid or angular than a normal blanket, despite NASA's official claim that the STS-88 photos depict a drifting piece of equipment. Nonetheless, an object's reflectivity and orientation can significantly alter how it appears in pictures. Sunlight in orbit can create intense shadows or dazzling highlights that hide an object's true shape. There was no indication of a new stable satellite in Earth's orbit based on telemetry data. Above a certain size, orbital tracking entities follow objects, particularly if they maintain steady orbits. According to NASA, the object ultimately fell into a declining orbit and burnt when it re-entered the atmosphere. The space shuttle worked at elevations where debris usually stays for a short time. The image endures as an illustration of how uncontextualized images can elicit notions of a structured craft. The date and location of the photographed object, the moon rings, are consistent with NASA's archived flight logs for STS-88, which indicate that a thermal cover was lost. In order to document earthquakes and other vibrations, astronauts placed seismometers on the lunar surface during the Apollo missions. Intentional impacts of rocket stages or lunar module ascent stages onto the moon to produce seismic waves were among the observations made during Apollo 12 through Apollo 17. When these waves lasted longer than expected, a noteworthy outcome occurred, leading to the expression, "The moon rang like a bell." Fluid elements in the core and mantle, as well as intricate layering, dampened seismic tremors on Earth. Because the moon's interior is dry and devoid of a sizable molten zone, reverberations last for a long time. Following these intentional collisions, seismic signals were occasionally recorded for up to an hour. When natural meteoroids struck, the phenomena also happened again. The lunar crust and mantle transmit vibrations in a different way than the layers on Earth, according to an analysis of the recorded waveforms. Results indicate that there are fissures and thermal or chemical characteristics in the moon's outer shell that lessen seismic energy attenuation. NASA does not suggest that the moon is hollow, despite the fact that researchers used the simile of rang like a bell. Rather, energy can spread with little damping due to the lunar crust's structural composition and dryness. More information on the moon's internal stratification, including a crust, mantle, and small iron-rich core, was uncovered by data from seismometers used during the Apollo era, which are collectively referred to as the passive seismic experiments. Periodic moon quakes were also noted, some of which were brought on by Earth's tidal forces. Because the moon's interior is dry, there isn't much moisture to absorb seismic waves, which could explain why vibrations might continue more uniformly. The network of seismometers eventually stopped working once Apollo ended, and the unprocessed data was stored. Some of the records were recovered by later programs, but others had problems with digitalization and archiving. In order to improve our understanding of the moon's interior, modern assessments use updated models and computational approaches. They mostly conclude that the ringing effect is caused by low damping capacity and significant fracturing. The official seismic data never supported the idea that the moon might be a hollow or artificial body. According to investigations, the seismic and gravitational profiles correspond to a rocky object that was created by well-known astrophysical processes. Thanks for watching another episode. Please like and subscribe for similar content.